It's a really hard act to follow after two of the very good speaker. But again, good afternoon. First of all, I would like to thank you for giving me the opportunity to share with you NanoDew. Now, NanoDew is basically a zero energy dehumidification and water harvesting technology that have been developed in our laboratory. Now, let's take a look first. What is the current world situation? At this moment, there's about 7.2 billion people around the world, correct? And 60% of them, 60% of the world population of about 4.5 billion people are actually living in tropical or subtropical zone, okay? And most of these people are living in large cities with more than 10 million people, okay? And some of them in mega cities. In fact, mega cities account for almost 9% of all the populations. And these mega cities consumes about 9.3% of global electricity, or about 2,000 terawatt hour. So what is the problem that most of these cities and half of the mega cities encounter? Just like Tokyo in Japan, Jakarta in Indonesia, Calcutta in India, okay, Shanghai in China, Manila in Philippines, and even in Hong Kong, we experience hot and humid weather. How do we solve it? We solve it by using air conditioning. In fact, if you walk around Hong Kong, most of the building facades, one of the most prominent thing that you see are these air conditioner, okay? Now, let's look only at those mega cities, half of those mega cities that are located in tropical and subtropical places. These mega cities consumes approximately 300,000 gigawatts hour of electricity in domestic and commercial establishment, okay, and pump out approximately 1 billion tons of carbon dioxide each year. A big proportion of this energy, about 50,000 gigawatts hour, is actually used for cooling. And 50% of this energy is in fact wasted in cooling and condensing moisture in air. You don't need to cool down the moisture if you can actually remove it. Now, the technology, basically, if we have the technology to remove the moisture before it gets cooled down, what does it mean? What does it translate? It translates to 1% saving in global electricity. That is equivalent to 25,000 gigawatts hour. $2 billion, okay, in real monetary savings for the consumer, okay? At the same time, you actually eliminate 100 million tons of carbon dioxide, okay, that will actually end up in the atmosphere. Now, let me talk a little bit about the technology that we developed. First, the solution that I'm going to present is started as a problem for us, okay? Why is it a problem? We have been working with a team of physicists at HKUST. We are trying to make superconductors. And one of the steps in their test of superconductors, they need to take our material and suspend it in oil. And they keep on complaining to us, you know, when we put your material in oil, it actually keep on attracting moisture from the air and form droplets inside the oil. This is very strange and also at the same time very intriguing for us. So we take a look a little bit more closely what is actually happening. We found that the material that we made, okay, loves water so much that it's actually pulling moisture from the air. Immediately, I can see the potential application. So one of the things that I did, I asked Dr. Ferdusi, who unfortunately is sick today, so she didn't join us, okay, to go to the grocery, okay, buy a sack of potato, rip the sack out, take the nylon, okay, and what do? We coat the powder on this nylon, put it between two posts, and then bring it up to my office and let me have a look. And this is what we saw. In fact, in room, you have only 60% relative humidity. At room temperature, it is start taking water from the air and then turning it into liquid, which came up as a droplet, which you can then collect at the bottom. And we had tested it, okay, and in fact, like the one of the a unit that we have had been working for the past 200 days. You don't need any electricity. All you need to do is to pass the air into these materials. So this is our solution. Now, let me talk a little bit more about the technology, what it is exactly. The technology, okay, the material itself looked like a blade of grass, okay? But it's 1,000,000 times smaller. Same as a blade of grass, it actually collects moisture from the air, condense them into liquid droplets, which you then can collect, okay? Now, over the past 18 months, okay, we had been starting to find out more about why it worked and how it worked. And this enabled us to redesign and re-engineer the material so that now we use material that you commonly found in your household, okay, to make the material itself. So making it, in fact, safe and also green. And in addition, we also did cell line study. We also did animal study to prove that indeed it is safe. It is inexpensive because calculation on the material cost, it will not cost more than $10 per kilogram, okay? And it is scalable. The powder can be produced in mass quantity. And along the way, we also start to think more about what we can do with the material. One of the things that we did is to make it smarter. Smarter in what sense? We can make material that will start to collect moisture, remove moisture from the air when the humidity is above 40%, or above 60%, or above 80%. So this way, now you can see the application is much broader. So you can actually use it to control the humidity. And at the same time, okay, we said, okay, the water that we collect, is there any way that we can actually recover it? It's not a waste, it's actually a resource, okay? Now, what we did is like we incorporate, okay, function that allows the use of light in order to disinfect and decontaminate the water as it is being produced. Now, it doesn't need any energy except the energy that you needed to push the air across the material. And then it therefore can be used off-grid. And what I can say is really truly a zero-carbon technology. Some of the applications that we have looked at, some of the really easy one immediately, is dehumidifier. You can package it into a unit, put a fan blade on it, blow the water across it, and blow the air across it, and it will start removing moisture, okay? Now, other things is like you can also use it in existing appliances. You can put them on coat them as a powder, spray them, paint them. On the evaporator coil, let us say of air conditioning, dehumidifier, or even your refrigerator, so that it removes the moisture before the air go in so that you can save a lot of energy, okay? So that will increase the energy efficiency of many appliances. You can use them in air purifier because like moisture is one of the major causes of microbial growth, okay? Now, other things like, for example, in fruit production and storage where humidity plays a major role, as well as in many industry and manufacturing. It can also be used maybe in remote installation because it doesn't require any energy to do reverse desertification. It can pull moisture from the air, precious moisture, bring it into the ground, allow plant to have time to grow and hold on to the soil and prevent desertification. Or even use it to supplement water need, okay, in areas that have actually poor access or little access to clean waters. So these are some of the things that we can envision. So what is our dream and hope? Let us look at it. For megacities, wherein we can affect about 500 million people, okay, immediately we know that it can actually decrease the electrical usage, save on money, and then at the same time, okay, reduce the carbon dioxide emission. And it also have a very positive effect because the less electricity that you use, the less amount of waste heat that you generate, okay, then the city will be cooler. It will require less electricity again in order for you to do cooling process. So this is have a very positive feedback loop. Now the other things that we would like to see is like people that are living in arid and semi-arid regions around the world. There are almost 2 billion people out there. So they don't have enough water. Can we use this technology to at least allow them to meet the minimum WHO, okay, suggested amount of water that a person need in order to keep healthy and keep its hygiene, okay? Can we somehow slow down the desertification process in order to save 1 million hectares of land, okay, that are very precious, that are needed for agriculture to support our population? Is it possible for us to do that? This is the dream and hope that I had. Because recently, 2 weeks ago, I went to Singapore with my son. We went to this garden by the bay, and then we went to this show called like 5 Degree. Okay, it is a documentary that say what will happen to the world, okay, if it goes 5 degree with the climate change. After watching it, he actually felt ill, and he asked me, "Dad, when I'm on your age, is this what I'm going to look forward to?" Okay, this is something that is very disturbing. Okay, if a child of around 9 can see what may happen, okay, and this is something I said, this is a technology that will plant a seed toward a broader type of solution. So what we would like to see is like from you is how can we make this dream come true? Okay, how can we actually bring this technology out there, okay, and start doing some good? Thank you.